All right, everybody. We're going to get started with EPL version 4 training. Is it still recording? Yeah, good. Oh, it looks like it's showing the,
I could wait.
okay.
Yeah.
But I don't want it to. Like this window is showing up on the go-to webinar.
I'm not sure if they can see it though.
Oh, you're right. Okay, cool.
I think it's just
Yeah.
if people here can see it. Yeah.
All right, so Energy Pro Lite, I'm going to kind of blast through this part just because I want to focus on the meat of getting you all familiar with the tool and familiar with its recent specification updates. So Energy Pro Lite, MFHERC, Multifamily Home Energy Retrofit Coordinating Committee, that's a mouthful, I know, is a group of stakeholders that's been convened since I want to say 2008, 2009. In 2011, they came out with a report that recommended that we really need a modeling tool that's specific to existing multifamily buildings. And what came out of that was the first version of Energy Pro Lite, which was launched in 2013 with the PG&E program, just being used by technical systems staff. So that would be AEA and San Francisco Department of the Environment. Last year, that was updated over time. There were multiple version updates associated with that. They're relatively minor. Earlier this year, we were able to roll out use of the tool to raters like yourself. And so you could use the program for Bambi to submit projects and for MUT projects to kind of tee them up and do an initial analysis. Because as you'll see, it's basically a pared down version of the Energy Pro Full software. So it's easier to take the information that you're gathering on site, enter it in there, enter some site-specific measures, and get a report that gives you an idea of what you can do on that site and the associated savings. The most recent version update of the tool, going from version 3.1 to version 4, has been funded by a grant that I manage from the California Energy Commission. Next slide, please. And this is a list of all of the specification updates that we were able to integrate into the tool for version 4. So as you'll see, it's pretty comprehensive, and we'll go over this with Maya as she uses the tool, and we go through some example projects. But a lot of stuff that was external to the tool in terms of calculations, spreadsheets, things of that nature have now been internalized. That includes lighting, domestic hot water, recirculation, pump control, pipe insulation, some other stuff as well. Electrification is a big one. That was obviously a pretty heavy lift for us to get that into the tool, and we're excited about it. Laundry, we're also calculating water savings. That shows up in the report. So if you're putting in faucet aerators or low-flow shower heads or new toilets, you'll be able to get a gallon savings in the report. Smart thermostats have also been implemented. And then this is the one I like the most because I've been on your side of things, and I've seen the outputs from these tools in terms of they're really just for kind of energy code compliance. And if you hand that over to a building owner, they don't know what the hell that is. So we were able to take some of that information and put it into a one-page report that I'll go through later, but it's owner-facing. So it kind of says, here's where your project is, here's the contact information for the person who put together the report, here's your estimated savings, some greenhouse gas equivalencies, and then just a table that simply lists the measures that are being considered for that site-specific project, their associated kWh and therm savings, and as I mentioned earlier, too, water savings if those are relevant. I'd like to note that EPL files can be exported to Energy Pro 5 full if you need to. So if there's some sort of, there are part of the reason Energy Pro Lite is, pared down, easier to use, is because we're making some assumptions in the tool. I won't get too much into it because there are workarounds, but if you cannot accurately model a building using this tool, you can export it to Energy Pro 5 Full. An example of that would be you have multiple different heating system types in a building. So like you've got gas wall heaters in half of the units and then a central hydronic system or electric baseboard heaters in the other half of the units. EPL can't do that. If you have window geometries that are really wacky and not consistent, there may be a workaround, but maybe not, and you would want to export that to Energy Pro 5 and work on it there. Where I can, in leading you through this, I'm going to give you tips on how to do workarounds for if you have like different input capacities or efficiencies for boilers and things of that nature. You can still use EPL for that. Next slide. Installation. So I was going to exit out of the PowerPoint here and show you very simply how you can install the EPL tool. And it's an install file. We'll probably be making that available, I hope, in the next week or two through the website that we've created that I'll show you in a bit. It's a pretty simple installation. Let's just go in. Let's go here. Go. So there's a wizard. And I should mention too, as Maya's going through this, there's a physical copy of the individual user agreement. So your program already signed a program agreement. If you're going to use this tool, version 4, we're going to need you to sign that physical copy and return it to me today. If you're calling in online or you have colleagues who are going to use the tool who aren't here today, the user agreement is already on the Radar website. So they can just download, sign that, scan it, and send it back to us. So yeah, here is a digital version of that, but we need you to provide the signed copy as well. And you would just go to I agree. And, from a legal standpoint, if you need somebody to review it, sure, go ahead and do that. We've had some other large consulting companies have their legal teams review it, and they were okay with it. And so, but if you have an issue, let us know. So hit next there. And then, if you want everybody using the computer, I would suggest hitting everyone instead of just me. And then you'll see here, and then you'll hit yes here. It's a relatively quick install process. Yeah, there have been some issues depending on which version of Windows you have. You might have to install some .NET software. It's worked pretty flawlessly on the computers or the machines that we use it on. If you do run into an issue, we've probably run into it before and we can help you. All right, so we're going to start off with a project. Maya, if you can open that typical EE project EPL file from that. Is that open? Yeah. So we're starting with kind of a deep retrofit project, and then I'll go into an electrification project. So I'm going to be standing up here, and Maya, who, as she mentioned earlier, she was really instrumental in developing the tool. She's been great to work with. We've also been working with Martin Dodd, who has headed up Energy Soft for a long time. He's the guy responsible for creating the Energy Pro software. And we also had a few other folks from AEA helping out with us. So this has been a long and involved process, and we're happy to be at this point sharing the tool with you. The other thing I should mention before I get into this is this tool is currently free. Again, it just requires that your program sign a program agreement, that you provide the user the signed user license. And that's because this most recent update to the tool was state funded. So that's a great thing. Yeah. So this whole webinar today is being recorded, and it's recording my voice. It's recording what we're doing on the screen as well. So sometime in the next week, I'll be uploading the recording to our website. And again, anybody who wasn't able to attend but wants to use the tool for MUP or BAMI is going to have to watch that webinar and let us know that they did that. Okay, so now getting into the actual use of the tool, I'm going to ask that folks hold on to their questions. If you do have a question, just write it down, because we've got a lot to go through, and I want to make sure we just get through it, and I'll leave some time at the end to answer specific questions around how you model specific things. So this is the project information tab. You'll see it's pretty straightforward here. You're going to enter the project information in terms of the project address, the customer, that's the person you're preparing the report for, usually the property owner or the decision maker at the property. The thing that we had, you add the modelers. I think that's up. You go to user information. So you want to put your information in here too, because this is going to show up on the report. And whoever's getting that report, we all know there's a lot of kind of changeover in on-site staff at buildings. Maybe the owner decides not to follow through with the project this year, but pulls this report out again next year, and they want to go through with it. You want to make sure you enter your contact info so they have that clearly on the owner-facing report page. All right, thanks, Lana.
I'll just add a note that for the licensed user, it'll stay with every model that you build in the future. So you really just need to enter it once, and it'll tie over to all future projects.
Great. And then in location, you can see here our example project is in Fresno. This is important because it determines the climate zone that the modeling software is going to use for your weather data. So can you open that, Maya? And basically every small, medium, large size city is in this list with weather data preloaded. If for some reason your city, the city that the property is in is not here, just pick the one closest to it that is in the list. Good on that. Utility rate schedules, generally leave that undefined. It might be useful in another version of the tool when we're able to have an updated utility rates in there and prepare some paybacks, but I'll get into that later. I'd suggest just leaving that undefined for now. So now into taking the information that you're gathering on site and entering that into the tool. We start with the building tab here in the project configuration section. So for this specific project, we're looking at one building, 2 stories. It was built in 1970. The total building floor area, that's common area and residential indoor conditioned space, is right there. Hallway floor area, that's conditioned hallway area. It also includes kind of common areas within the building. So that would be, if you have a community room or a leasing office, you want to take that into account here in terms of its square footage. Going down here, we're looking at number of dwelling units, number of kitchens. Those usually are congruent. For refrigerator, so a lot of properties, newer properties sometimes have, all the same refrigerators in all the units. Most times they do not. So what you're doing when you're on site is you're out there sampling these projects and you're getting the make and model info for those refrigerators. And based on your sample, you might have 2 or 3 models that you're seeing in the building. What you're going to do is you're going to take the usually Energy Star rated annual consumption of that, those refrigerators and just average them. So let's say you sample 10 units, right? 8 of the units have one refrigerator, we'll call it refrigerator 1. 2 of the units have refrigerator 2. So 80%, you can assume 80% have refrigerator 1, 80% have refrigerator 2. You're going to take the annual consumption for refrigerator 1, multiply it by 80%, or no, sorry, you're going to take the annual consumption for refrigerator 1 and multiply it by 0.8 or 80%. Then you're going to add to that the annual consumption for refrigerator 2 and multiply that by 0.2. And that's going to be your average value for the building. So that's a workaround with EPL that you'll see kind of as a theme as we're going through it, is taking the averages. So in this case, we put 550.
I'll just add that this is per unit. So this is going to be the average refrigerator per unit. It's going to be multiplied by your total number of units that you enter at the top.
That's right. Thanks, Maya. For oven type, you'll see that drop down. Gas, electric, unknown. I would not suggest using unknown. I think it does some sort of hybrid calculation between the two. If you're on site getting into those units, you should know what the oven is. Number of bedrooms. So that one is generally, unless it's all one bedrooms or studios at the building, it's going to be more than your number of units. So however many studios or one bedrooms, those are going to be one bedroom units. Then if you have 2 bedroom or 3 bedroom units, you just want to make sure you're taking into account the total number of bedrooms at the property. Now on to the wall length and orientation. So for this, you're going to, I think what most folks do is they go into Google Maps, or you can download a free version of Google Earth, and you can zoom into your property site, and there's a dimensioning tool that allows you to measure the linear distance of the different facades of the building. And what you're going to want to do is measure those lengths. So for this specific project, 0 is, I believe, Maya, congruent with true north, right? So this building is a box, and it has an 80-foot wall facing north. It has a 150-foot wall facing to the east, another 80-foot wall facing south, and a 150-foot wall facing west. If you have different orientations that don't line up with the cardinal directions, you're basically looking at north being 0, all the way 100 to 360 coming back to north, basically. So 180 is due south, 90 would be due east, 270 is due west. Some buildings are not orthogonal or rectangular. That's fine. Just make sure you're entering all of the sides of the building into the tool, and it will perform the heat loss calculation such that shouldn't be an issue if you have kind of an interestingly shaped building. Now going on to construction type here. If there's no crawl space or it's not on a podium over a garage and it's just on a slab, you would check that box. So within this building, within this box right here, the construction box, we're defining the building envelope. So for floor, in this particular case, we are picking the R0 floor crawl space. This building is wood framed. So it's basically going to have some sort of stem wall foundation, and it's going to have the lower floor will be above a crawl space. Even if there is a basement or something like that, but it's still wall construction, wood construction floor, you would choose this. If there is some amount of existing insulation, for this, in this case specifically, say like if you have for a crawl space with some insulation, you could pick something like R13. You would want to crawl into the crawl space and figure out what the existing insulation is. I do want to highlight here, Maya, if you have like a concrete building and what we can do for that. So we'll show you how to do that. What we'd do first is hit this plus button. then it will highlight this. It just copies what you already had. But then what we're going to do is import a floor. And it's going to be concrete raised. And basically, does it have insulation underneath it? A lot of concrete podiums do have some sort of sprayed on insulation. I've seen that, which is fiberglass bat, which is kind of weird. That's not typical. Or it might have no insulation at all, in which case you would scroll down to the bottom of this. Let's see. Is that one in there?
I think you just used the none.
This one says insulation underneath, but you'll see for listed insulation it has none. So you would pick that if you've got some sort of concrete floor that's raised that doesn't have any insulation. So that's how you would. And then once you choose that, you would want to rename it specific to the property. So, uninsulated raised slab floor, or something like that.
And just to clarify, this is the exact same J4 library that you have in Energy Pro 5, so it should look very familiar. It has the same defaults as well.
And I want to clarify too, because I've seen submissions where there was a concrete building built in the 1960s, and some people, actually, there's a good example of this, I think, when we get into walls, so I'll wait till we can close out of floors. If you go to wall, okay, great. This is another example. For this specific example, we have R0 walls, wood-framed R0 walls, 16 inches on center. You can see all that defined here. There are a bunch of wood-frame walls that you can find predefined there. I've seen examples where you have a 1960s concrete building, maybe it's a mid-rise or a high-rise, and the modeler assumed that because it was built before 1978, which is basically before Title 24 code went into effect, they could just choose that. Not the case. That specific library item here for walls, as you can see, assumes wood frame 16 inches on center, but that's not what we have in this other example that I'm using. It's a concrete building. So in that case, you're going to do something similar to what we did in the last one, which is hit the plus button and then go to import wall. And generally, if you're in a concrete building, you can go to a unit or a window that's in a common area in that building, get in and look down and see, use a ruler or a tape measure and figure out what the thickness of that wall is, where the window is, because you can have access to see where it ends on the outside, where it ends on the inside, maybe subtract the amount of drywall or exterior siding that it has. And what you'll want to do is go down to, I think it's over here, my solid unit masonry. And then if you scroll down, most concrete kind of mid or high rises have walls that are between 4 and 6 inches thick. So you would choose one of these, and that would serve as your defined wall for the property. Is that clear to everybody? Cool. All right, so we're good on wall. Oh, and then again, thanks for doing that. You can put in 5-inch concrete. And I'm thinking, yeah, that's fine. So for this building, it's an R0 roof attic. Again, if it's concrete, we don't need to go through it. I think it's been pretty clear from the last two examples, but you would just hit the plus sign and import the roof and do like a 4-inch or a 6-inch roof. A lot of concrete buildings have exterior added foam insulation. So if it does have that, just enter the R value of it here, and that will calculate for you. Great, thanks. All right, for glazing. Generally, if your building has either single pane, if your building has single pane metal clear windows like this example, that would be like your classic kind of 70s, 80s building with aluminum kind of rickety windows. That's predefined in here as single metal clear. So you can just use that default. And a lot of the time we see single non-metal clear. So like in San Francisco or Oakland where you have old Victorians, that would just be single non-metal clear. That would be the one you'd want to use. And then if you have a newer building or the windows have been retrofitted and they're double pane, they're usually some sort of vinyl or PVC. That would just be double non-metal clear. If you notice some sort of tinting on it, you can use tinted. But what the default should correspond to what's installed at the building. If for some reason you're there and you can get the U value and other very specific information about the building, you would just hit that plus button and create your own customized window based on the specifications that you have. Or maybe you have the plans that the building was originally constructed with, and that lists the spec information for the windows. You can do that here. And you would just update all of this information that you see to the right that Maya's playing around with. I want to highlight that if whatever you're putting in, number of panes, that should be either single pane, double pane. Maybe I doubt you're going to see triple pane, but maybe. Frame type, that's pretty straightforward, tinted or non-tinted. That's just based on what you're seeing visually, basically. I do want to highlight operable. That has some effect on your window heat loss calculations, and if the units primarily have windows that are operable, you'll want to check that box. So, okay, that's windows. Now, infiltration and ventilation, I might defer to Maya on some of this stuff. Shielding, you'll see the drop down here. Well, first of all, you'll see this number ACH, that's air changes per hour. That's used in the calculations for the tool, but you're not directly entering that. What we were able to do, which I spoke about earlier, is internalize some external tools. So we used to have a spreadsheet calculation that you could use to determine the ACH number. Now we've built that into the tool, and it's based on these drop downs here. So for shielding, that's basically the building is out in the middle of the field in the Central Valley with nothing around it. Well, then it would be exposed. Is it normal? Normal and well shielded. I might defer to Maya on those descriptions.
Yeah, we have a more detailed description in the user manual, but I would go with normal for most buildings in the Bay Area, and well shielded would be in, for example, like downtown San Francisco or downtown Oakland, where you're like right up against a bunch of buildings, and so you're really well shielded.
Yeah, I think well shielded would also mean that those buildings are right next to you and they're either the same height or even higher.
Yeah, exactly.
But, I mean, it's not necessarily San Francisco close, like Seattle Line close. I mean, are we talking 10, 15 feet building distances or 20 feet building distances? Well shielded or?
Yeah, I'd have to refer again to what we had in the manual. I think it has a bit more description, but I would say kind of use your best judgment. You'll notice for example, if I select well shielded right here, it's going to reduce that ACH. So I'd say normal is a good place to start, and then if you have further information to kind of indicate one way or the other, I'd go with that.
And then do you want to touch on leakiness now?
Sure, yeah. So again, this will be in the user guide, but really normal will be the standard unless you have additional information. So tight would be, recently built, really well sealed, new vinyl double pane windows. And then, for example, leaky would be probably closer to like pre-1980s construction, pretty leaky in general, those flimsy single pane windows, that sort of situation. So again, the user guide has even further details, but I would stick with normal unless you have a lot more information to kind of sway you one way or the other.
Yeah, and on the leakiness, you're going to get a pretty good feel for that on site by talking to the facility staff and tenants and asking about their thermal comfort within the building. If they're saying it's drafty, if it's cold in spots, even when the heater's on, you can pretty much assume that it's a pretty leaky building. What's that? In terms of just all over the place? And yeah, if you're working in older buildings, I'd agree. Newer buildings, not so much.
Yeah, so sometimes there's a price to depend on what your area is, because they know their buildings.
Mm-hmm. Yeah, and this is a value judgment. You know, this is one where we wanted to give you the option of picking the drop down here. And we would have pictures and hopefully some qualitative description in your report that would back that up. But it's really your call. But we are going to verify that based on the information that you submit to us. Maya, I'm going to turn it over to you for the fans down here as well.
Sure, yeah. So for the kitchen exhaust fans, this will be the total quantity of exhaust fans in the entire property. So typically, it's either most likely going to be 0 or equal to the number of dwelling units. Sometimes you have, mixed match, but that's typically what you're going to see. And this is all about infiltration and ventilation. So we're not talking about recirc exhaust fans. This is exclusively ones that are ducted to the outside. And then same with bathroom exhaust fans. This will be the total number. So you'll want to create a calculation including like the number of beds and baths, and then add in the total number of bathroom exhaust fans. And the default here is that they're intermittent bath exhaust fans. And then if you check this box, that will indicate that those bath exhaust fans are continuous. And to be honest, this is really only found in like new construction buildings right now, but we did want to give you that option if that applies.
Yeah, I'll add on to that and say that recently constructed buildings, to meet their ventilation requirements, some of them have installed bathroom fans that just run continuously. For intermittent, it assumes that if you don't check the continuous. What do you mean by that? Right. So the question is about kind of if the fan has some sort of existing control and it's not continuous. Yeah, the model is making an assumption that there's a control there, whether it's manual or on some sort of occupancy sensor. I think it probably averages those out.
Yeah, exactly.
So again, that's kind of a value judgment when we were developing the tool, where we wanted to make a bit of an assumption there for how that intermittent is calculated. So we kind of average that out.
And then just wrapping this section up. So if you have a situation in which you have rooftop exhaust fans that serve all the units, for example, if those served all the bathrooms in the property, you would set this bathroom exhaust fan to 0. You'd have your other continuous exhaust fan. So let's say you have 5 rooftop exhaust fans that serve all the bathroom stacks throughout the property. Then you'd insert that average CFM per exhaust fan. So these last two data entry sections go together exclusively. So this average CFM per exhaust fan has nothing to do with the kitchen or bathroom exhaust fans up here. It only will interact with this number that you have right here. So if you have an average of, let's say, 400 CFM per these 5 continuous exhaust fans, that's what it will run as additional exhaust beyond what you've entered here. So if you have a mix, you're welcome to add that in too. It'll all be incorporated into the calculation, and it will all automatically adjust that ACH at the top. So you can see by adding those large continuous fans, we've increased that ACH to 0.7 from about 0.3.
Yeah, that's an important one to note. Again, I think that example that Maya provided is for newer buildings where you have a centralized exhaust system that's pulling air from the units. They're joining the ducts as they go up through the vent stack up to the roof. So that's kind of how you model that specific situation. And I'm getting kind of a nod from Maya, but that might be older buildings as well that have that particular setup.
Yeah, I would say I see that in, like, a lot of kind of pretty old, like, downtown San Francisco buildings as well, but it's a wide range.
Cool, thanks.
For clarification, so if the kitchen exhaust fan is not exhausted to the outside, you're not counting it?
No.
That's correct.
The bathroom exhaust fan is not exhausted to the outside, you're not counting it. If it is exhausted to the outside, but through a shared stack, you don't count it there, you count it in particular.
Yep, that's correct.
All right.
And the average number is only for if there's any other. So we're not sampling.
So to rephrase what was just said here, if you have a recirculating fan in the kitchen or bathroom, you are not entering any information for that. It's only if it's exhausting. Maya, do you want to add to that?
No, I think that was all correct. And then I would just clarify, when it really comes down to it, what are we looking at? We're looking at infiltration and ventilation. So just kind of keep that in the back of your head as you're working through these questions.
Yeah, these recirc fans are just recirculating air within the building. They're not ventilating in any way.
I think my confusion is that if you do have true kitchen and true individual unit exhaust fans or sampling units, are we sampling for an average CFM for those individual exhaust fans? And I think the answer is no. Yeah,
that's correct. So there are no, the model assumes kitchen and bathroom default CFMs. We've found that in our experience, it can be challenging to get accurate readings of those exhaust CFMs unless you're testing it accurately. So we have, it's integrated kind of behind the scenes. It assumes a default intermittent CFM.
Okay. Great. So I think we can move on to lighting. Lighting was a big one, and still may need a little bit of work before we share the install file with you guys. But this is one where we have these big clunky spreadsheets that I'm sure you all have and are familiar with, and maybe a pain for you to fill out. I know they were for me back in the day. So we took kind of spreadsheets that we've been working with both internally through our technical assistants and through leaders, and tried to pare it down to something that could be entered into the tool and still usable. So this is a pretty simple example, but you can see here within this table that we have existing kind of 60-watt incandescent bulbs in some of the unit kitchens, bathrooms, and bedrooms. The unit exterior has a 2-lamp with incandescent bulbs totaling 80 watts. The laundry room has this 2-amp 23-watt CFL. And the exterior, again, these are all existing, has an existing 15-watt LED. So we're putting those wattages in here. And it's not the bulb wattage, it's the fixture wattage. So I don't have an example up here, but say, if it's a 2-amp, 4-foot fluorescent fixture, we all see those all the time, whether they're in garages or hallways or even in units. You're going to take that fixture wattage, which is typically going to be less than the nominal wattage of the lamp. So if you have two 32-watt T8 lamps, you have an existing kind of normal electronic ballast with a normal ballast factor. The typical wattage you'll see for that is 58 watts. So we would just enter 58 in there and then the quantity. If there's any kind of aux sensor, you're going to check that box. And then the space type, that's pretty self-explanatory. You can see the drop down here. Where is that fixture? Find the space type. Generally, it's going to be unit interior, unit exterior, some sort of common corridor. That'd be hallways. Could be in the garage. Could be in a community shared space. Is there a game room or some sort of community room? And then you want to take into account exit signs as well as common area, exterior, laundry. That's all pretty self-explanatory. And in these parentheticals within the drop down, that's the assumed wattage that we're using. And that's congruent with
the hours.
approved by, that's the annual hours. So out of 8,760, which only applies to parking garages, you have these other values that we have to use for the program for calculation purposes. So there's no flexibility on that. Then what you're entering is the upgraded wattage. So in this case, that might be a little bit higher, but it's just an example that we're putting in a 20-watt replacement bulb for that 60-watt incandescent. We're putting in a 12-watt replacement for the 40-watt incandescent. We're putting in, if this is 2 lamps and it's 23-watt CFLs, you're getting that 46 existing wattage. Here we're proposing to basically 12.5-watt LEDs. And then there's no change for the exterior because there's already an existing LED. So we're going to enter the same wattage. We're not entering 0. And then if there is some sort of change to the controls for the lighting, all we can model right now is bi-level or occupancy sensor. What would you enter if it were time clock or photo cell?
I would probably recommend calculating that externally and then entering the upgraded wattage as the sum. So for example, and this actually goes for really all of it, you can enter in as many rows as you'd like of this lighting, but I would say to save you a lot of time and hassle, it might make more sense to sum all of your in-unit lighting in one section and then enter the total wattage as one line item, and same with the upgraded wattage. So it's really up to you if you want to enter line by line, but you can calculate it separately and enter the total upgraded wattage, including any controls calculated separately. Does that make sense?
No. The question was, is there a way to upload the lighting spreadsheet?
That's a future goal. That would be great.
Yeah, potentially. So I guess I was going to make a comment. This kind of ties into that, which would be, you can use EPL as a kind of quick analysis tool, or you can use it to, make a formal submission to the program. If you're doing the quick analysis, maybe you're just using this table up front. If you're making a formal submission, your problem and your lighting is going to be part of your project scope. You're probably still going to have your own internal lighting spreadsheet. So you can take what you need out of that, specifically for the example that Maya just presented on a control that's not in the drop down. You can come up with a workaround where it's captured in the wattage. Okay, let's move on to HVAC. So this is, again, we're thinking about a building that's 2 stories based in the Central Valley in Fresno. So we've got a forced air unit, a gas furnace. And so that one is actually in the default library. If you're on site and you're going into the units and you're doing what you should be doing and getting the kind of model info for it, you might find that you're not finding the specific make or specifications of the model that you're seeing on site. You would just pick whatever's closest, hit the plus button, and then modify what you have here to match on-site conditions. So for a forced air furnace, we're using split DX, and I can't remember, do we have cooling here, Maya? Yeah, we do. Okay, can you go back to heating? So split DX, split direct expansion, that's saying basically that we have a forced air gas unit in the unit, and we have an AC condenser that's somewhere outside connected to the unit. So for heating, which is the tab we're in right now, we're going to choose gas furnace. It's going to be, this is specific to the unit, right? So it's central within the unit. So we'll pick central. If you had a wall heater, can you just show folks what that would look like? We would go with the gravity wall, and then you would update the total output information and enter the efficiency down here. Supply temp, if you're measuring that on site when the heater's on, great. Otherwise, I'd say just stick with the assumption there of 105. Can you go back to the heating for a second? We'll do a heating hot water example later. All right, so going to cooling for this specific system. You're outside, you're looking at the condenser. You're going to make a model, and so this information that you see here in the cooling coil section might be listed there. You might have to get back to the office and look up the spec sheet for this model. Pretty straightforward what you're entering here. Again, supply temp, if you measure it, great. If you don't, just use 55 as the default. SEER, energy efficiency ratio, all of that information should be available through either the model information on the unit, or that you can look up once you get back to the office. And the condenser type in this example, it's air cooled, so it's outside, it's got a fan. Yeah, and then did we enter fan information for this one? Controls, oh yeah, I want to go over that too. Fan operation, generally you're going to do intermittent unless you have a fan that's running constantly, which I believe is rarely the case. And if it is running constantly, that's going to have a pretty big effect on your existing baseline, because it's going to have a fan running all the time. So in most cases, you're going to choose intermittent. Is there anything you want to add, Emma?
Yeah, so this is also in the user guide, but for any HVAC system where you have a fan, you'll select intermittent. And for any, like for example, a wall furnace where you don't have any fan, you'll select continuous. So I think it's kind of just a little trick that you'll have to learn. And you may already be doing this anyway, but just as a reminder, that's the guidelines.
And Maya keeps referencing the manual. I'll show you guys that. We'll bring it up after we're kind of done running through the program. So yeah, pretty straightforward here. Fan type is drop down. It's almost always draw through. Airflow, you're going to get that from the make and model information, as well as the design horsepower and the drive efficiency. Great. I think we're good on that. So for this one, again, it's a forced-air gas furnace, so it's ducted. Cooling distribution also ducted. If you click on those drop downs, just so people can see the other options, I'll go over a heating hot water example as well a little bit later on. The duct location, that's pretty important. Here it's in the attic. The ceiling is insulated and vented. If you hit that drop down for duct location. Yeah, so you can see all of the options as to where the ducts are. That should capture just about every case. If you go back to the cooling distribution drop down too, that's it. If it's ductless, if it's cycling refrigerants around to a mini split or something like that, you would choose that option. Duct leakage, if you're testing it, put in a specific percentage. If not, I believe you're leaving 36 as the default. If you look at the ducts and you see that they are insulated, you want to put the R value there. Let's see, that might be a good time just to run through the centralized heating hot water example. So in that case, you would go back up to HVAC, and you would pick, let's see, I believe, create one here, yeah. So here we're going to go heating hot water or hydronic system. And this is a bit weird, but it's a split DX. That might be counterintuitive to some, but we had to have a workaround. And this calculates it pretty closely to what it would be in energy profile full. So for hydronic heating, you will select split DX. And then under heating type, you select hot water. And that's going to gray out these because they're not relevant. And then the total output is going to be based on the radiators that you have in the unit. So if you're in San Francisco and you have steam radiators, you're going to need to do an EDR calc and get that BTU per unit. If you have baseboard hydronic, and you're going to need to do a calculation based on the linear footage of those to get the BTUs for that. Supply temp, you're going to want to change to 140. Generally, hydronic systems operate at a temperature where the hot water being supplied to the unit is higher than that. but that's the highest that it can go within the program. If you put in 141, it wouldn't let you do that. And then for the baseboard heat, you're going to put hot water. And then, so that's basically how you would model heating hot water at the unit level. So we can click out of this one, Maya. So if you have a centralized hydronic system, you would click on this and you would enter the boiler information here. We don't need to lead you through it, but you just enter the spec information. You can look it up. It might be in the library. If not, you just enter your own specific information. And then for heating schedule, generally you're going to use California 24-hour in-unit. If for some reason the schedule varies widely, well, it's generally going to vary widely because most units have some sort of thermostat, right? So it's going to be specific to that tenant. So in that case, where the tenant has control, this kind of captures, to the best of our ability, a way to average it across the building without you having to do some sort of exhaustive analysis. So we'll just go with that one. Cooling schedule, generally, I believe we're using, is that what you would use? California low-rise cooling?
It kind of depends on the program. I think each program kind of dictates the schedule. You could either probably California 24-hour cooling or low-rise, if that is better fits your property.
Yeah, and what you're seeing is if you click on one of these boxes over here, it's putting in the 24 hours of what the settings are for that system. And then it's just copying them to every day here. Cool, thanks. We'll leave piping out of this one because it's the same basically as it is for domestic hot water, unless you want to add something there.
Yeah, it's a little different. So this, just to be clear though, that this hydronic piping section is only for unconditioned piping. So the model already has set assumptions for pipe lengths throughout the building, and that's the same that's used in Energy Pro 5. But we found that in Energy Pro 5, there isn't any opportunity to add in additional unconditioned pipe lengths. So this is where we can enter that in if applicable. So for example, we saw in the boiler room a bunch of unconditioned pipes. We can add in that length right here, diameter, insulation thickness, and hours that it's running per year, along with choosing the type of piping. And then you'll see as well later on, there's an efficiency measure for this specifically to add in insulation onto those same pipes.
Okay, great. I'm realizing I need to speed it up a little bit. If you do have the hydronic system, you're just going to enter the information for the pumps right here. And if you need more guidance on that, it's in the manual. Moving on to domestic hot water, you're going to enter the boiler information. So up here at existing boiler, you're going to just enter the spec information for the model that you have. You're going to list the number of those types of boilers that you have. And the draw. The draw is something, again, a calculation that was external that we've now internalized. So if this is a market rate building, you'd probably just put average. I think affordable housing tends to have higher hot water usage, so you might pick the high hot water draw for that building. Or if you're doing interviews with on-site maintenance staff and you get a feel for some sort of percentage that you want to deviate from the average, you can enter a specific user percentage. Maya?
The real benefit here is if you have actual gas usage data and you want to true up your model, you're able to either enter a user percentage or adjust to this lower high percentage. There are a lot more details about kind of when and where to use this function in the user guide, but I would stick with average for now, and then if you're presented additional information from a utility bill, that's when you want to kind of implement some sort of additional alteration. So this user percentage, you could then kind of really true up your model by entering, 105% and kind of adjust the amount of hot water draw from there.
Great, thanks. And to go back to what I was referring to earlier, in a lot of instances, you have kind of a mix of different boilers for the hot water system across the property. Different brands, different input capacities, different efficiencies. You just want to average that out and enter the value here. So you would, if you had two different boilers and one was 200,000 BTU and the other was 100,000 BTU, the average would be 150,000 BTU, and you put that in here, and you'd probably, if they didn't have the same efficiency, you'd average the efficiency as well. You can do that with 2 boilers. You can do that with 30 boilers. I've seen it been done, and that's fine from a calculation perspective. What you're going to need to submit to supplement that here is some sort of table in your external calculations that's showing all those different boiler types and how you got those average values. For the pump system, the recirculation pump, pretty straightforward here. If you have a recirculation pump that's running 24/7, you're going to run, say, no control. If it does have some sort of control on it and you can tell what it is, you're going to choose it from this drop down. The next thing you would do is if there's more than one pump, you put that number in the pump multiplier. And if you know what the power rating is on that pump, you're going to enter it in here in horsepower. Again, if you have multiple different pumps, sometimes there are 2, maybe even 3, you're going to average out that design power on the horsepower. And if it's a wattage rating, you're just going to convert that wattage to horsepower. Let's see, and then laundry is pretty straightforward, but if you have a separate boiler, you can enter it in there. So that's often the case. That's something that we were able to add to this version of version 4. If you have gas dryers, you can click that box right there. Otherwise, we'll assume electric.
Yep. Okay.
And then for the common area washers, if you have them and they're top loading or front loading or in conditioned space, you choose all those things. And if they're in unit, you can toggle that information on and off based on the on-site conditions. The cool thing, another external calculator that we've now internalized into the tool is domestic hot water piping. And what we're entering here is all piping within the system. Do you mind just quickly leading them through how that would be related?
So previously on Energy Pro 5, we just have one section for piping in the plenum or underground or outside. And this basically just adds a little bit more interactivity and data gathering. So you're able to enter supply and return piping and indicate that with this supply button. So if you check this box, it'll be supply, and if it's unchecked, it'll assume that it's a return type. Then you'll enter the length that's associated with that. There will be a calculator provided to assist with that length calculation. And there's also guidance on the next step, which is diameter. So ideally, you're getting this information from the site visit, but if you're not able to, there is some good defaults to use there. And then you will also enter in the insulation thickness. So you can keep going with and enter in a bunch of piping as much as you want. And, you might have some that's already insulated and some that isn't, that you'd like to improve. And that can be done under the efficiency measures. Last to data entry is fiberglass or rigid foam. So if you check this box, it's fiberglass. Otherwise, it assumes that it's a rigid foam insulation. And then the location is going to be either the underground, outside plenum, or the boiler room. So there are different temperatures associated with each of those. So that will be built into the calculation and kind of calculated from there.
Great, thanks. That's domestic hot water. I just want to show you pools. I'm not going to go through it in detail. We don't get a whole lot of B&B projects with pools, and the folks, well, it's all pretty self-explanatory here. And based on older versions of the tool, we've brought in a lot more information that you can enter based on the existing site conditions. So you can enter the boiler information. You can enter more specific information related to the filters. I believe this is detailed in the manual as well. Or
basically, the only thing we added is this bottom section. So previously, we were not accounting for any pool or spa boiler usage, hot water usage at all. So now we're actually accounting for that. So by entering in the surface area and adding a associated boiler and heating schedule, we're able to capture the energy use associated with these pool and spas. So it's a pretty significant jump in energy usage that we weren't really calculating prior. So keep this in mind as you move forward with projects, that you will notice a pretty big impact on your total energy usage baseline.
And I also want to point out related to that, the heating schedule is important. A lot of these facilities shut down their pools in the wintertime. So you don't want to say they're keeping it at 80 all year long if in fact it's shut down 6 months of the year. And you can capture that here. And that'll make your baseline better.
Yeah, so I've done two. One is 12 months, and then one's a kind of traditional May to October set point. But you are always welcome to add your own or modify it with this plus button and alter it yourself.
Great. And then we'll look at efficiency measures, and I'll kind of breeze through this. In a nutshell, the efficiency measure, whatever you're entering for the efficiency measure from this list, you're entering the upgraded information. That's how it's being improved over what you entered before. So it's the same interface. We'll take, for an example, let's see, with attic done there, is that up at the top? Roof insulation, yeah. So we're going from R0 to R38, and we had R38 roof attic in the library here. So we can just enter that. Boom, it's done once you check the box. Windows, upgraded windows, you put in the specs of those. Smart thermostat, I actually want to go to that one. If you check it, we've got the beam savings already built into the tool. So boom, you're done there. Apartment lighting, if you check that, it's going to look at the drop downs in the lighting table. And if you entered apartment lighting, unit interior with an upgrade, it's gonna calculate that for you. Same with common area exterior lighting. Domestic hot water boiler, if you're doing an upgrade there, you're just putting in the new spec information for the condensing unit that you chose here. Pretty straightforward. I do want to mention the type. If you have a centralized hot water boiler that's feeding into a tank, that's going to be an indirect gas boiler. If you have a tanked hot water heater, a lot of those are in unit, that's just going to be gas fired. That's an important distinction.
I do want to highlight the addition of central heat pumps. So we always had individual heat pumps that would be for the kind of entire property, but we've added a central heat pump, and here you can add in your volume, input, and annual COP, and it's going to be calculated separately. I won't get into it because it'll take some time, but it's all in the user guide, and it gives a little bit of guidance around that. Additionally, I think if you're working with a program specifically, they can help calculate that and provide support around that calculation. But this is a new feature, and we're pretty excited about that.
Yeah, and I'm glad you did that, because we're not going to have time to go through the electrification file. So that's literally how easy it is to model electrification for the domestic hot water system here. It's just changing these. And then if you can go to just do a quick example of if we electrify the heating system as well. So for this specific system,
I'd probably copy a heat pump example, and then you can modify it.
And the specifications there, yeah.
And we've always been able to do this, but the addition of the DHW allows for you to kind of do it throughout. So I won't go through it.
Surprisingly straightforward. All right, so can you bring up the owner-facing report for the specific project. It's in the project file there. And normally what you would do is press this, and it would give you the file that we're about to show you. So it's in that project folder. Yeah. Electrification. Yeah, typical. Cool. So the owner-facing report, that one pager I was telling you about earlier, here we go. This is what you're getting and what you're handing to the decision maker of the property, whether that's the property manager or the building owner or some sort of asset manager. You know, it's going to have their name and info here, your name and info there, basic site information, where is the building, how many units, what's the square footage, savings summary, what is the total estimated savings, some greenhouse gas equivalencies over there, something that's kind of fun. We have a conversion to a number of gallons of gasoline that's being saved from a carbon perspective. And then this table is just the list of measures that you've picked in your efficiency measures within the tool. So you saw it in the tool. If you don't mind going back to EPL and going to efficiency measures, whatever you put in the narrative for the report is going to show up in the table. So if we go back to the table, what you write here. And so you'll see there's a fair amount of room here. We know it's small writing, but it's all we had to work with. You have 2 lines of text per row. So you could put in the name of the measure and the specific make and model info if you wanted to. That'd be a good thing to include. And then what it's going to do is it's going to list your calculated kWh and therm savings here. And you'll see we have water as well. And then it adds it all up at the bottom. Another cool thing you'll see is the terms. We realize that a lot of people you're presenting these to might not be familiar with, and terms that we're all very familiar with. So greenhouse gas, metric ton CO2, what is a measure, what's a kilowatt hour, a therm, DHW, HVAC, we spelled that out down there. So can you go back to the PowerPoint? And then I'll accept questions at the end because I know folks might be waiting to get at those sandwiches. I know I am. So that was a blast through the example projects. Maya and I have put together this manual, and I'll give her more credit than myself for sure. She did a great job, and that is up on the website right there. And for anything that you need a little more guidance on than what I provided today, it should be addressed in there. And if for some reason you're still not getting it or not able to model it, you can reach out to us because we want to know what might need to be updated in the manual. Do you mind actually going to the PDF of that in that
Sure.
project file just so people can get a feel for what's in the table of contents and how it's laid out?
Oh, I think it's still stuck on the PowerPoint.
You know what? Just keep it on the PowerPoint. I think drop the mirroring or the duplication of the screens.
Okay. Oh,
there it is.
hey.
Cool. So, it's typical if you ever use an Energy Pro manual, we use the same formatting to keep that consistent. And then we just kind of highlighted where, how things are modeled within Energy Pro Lite. We also provided some case studies at the end, which are example buildings and all the different systems and how you can model them. You'll see those here. So we're pretty stoked that we finally have a manual so that you guys, your savvy, intelligent people, can install the program and with this manual, hopefully figure out how to model these projects. And we just record it. We've been recording everything that we've been going over today, so that will be posted to the website as well if you ever want to refer back to how we were going through that EPL model. And then going back to the PowerPoint.
Mm-hmm.
And I realize we're going to run just a few minutes over noon here, but I'm almost done and can answer questions. Great. Next slide. Bug reporting. If you go back one more. So we realized we've done a lot of bug testing. We've been developing this for quite some time. The grant has provided limited resources. You're going to find some bugs. We want to know about them. So I'm going to make a form available at this website where when you click on it, it leads you to a form and you'll be able to enter your name and email address, the project name, what you're trying to model, the system being affected, and the description of the issue with a kind of step-by-step bulleted, however you want to do it, detailing how you modeled it and what you're experiencing that you think is limiting, or what error you're getting from the tool, anything that's not providing you the ability to model the existing building properly or the efficiency measures. And you'll want to upload the EPL file as well. So that I'll put a link into that, into the Radar page later this week. Potential updates for version 4.1. This is what we're thinking about. We're hoping we'll have enough funding to make this happen. A measure cost tool or a wizard, or the ability for you to enter the project costs on your own such that we can get paybacks would be great. So utility rate information would also make that payback calculation possible. We're looking at the ability to implement either existing or proposed PV or solar hot water. Again, payback analysis, probably putting some graphs into the report, and we might be able to turn this around depending on the grant, if we might be able to shift around some funding or get more funding in Q3 or Q4 of next year. Excellent. Document submission. This is the email address. We accept any form of document submission through some sort of a sharing platform. What I've typically seen is Dropbox or Google Drive or you name it, anyone. As long as you're sending a link in this email that allows us to download your project files, that works. And in the subject of the email, you're going to want to put in Radar submission for and then the specific project name. So that's what we'll use going forward. And I should mention this tool, once we make it available to you, you should be using it for 2020 projects. If you've already been to a site and you're using 3.1 already, that's okay. You might want to switch it over. That's up to you if you want to keep it in 3.1 because you've already done a sizable amount of work there. That's fine. But if you're going out to a site for the first time and you're coming back and you haven't entered the information anywhere, we want you to use version 4. And you're going to find it more useful because it's way more functional than version 3.1. And a lot of the stuff that you've been tediously entering in other external spreadsheets and things of that nature has been simplified and pared down, and you can use it here. Next slide, please. All right, do we want to do Q&A? I'm seeing some glazed over eyeballs. I know this was a little dense, but I'm excited for you to use this tool, and I hope you're excited too. And it's going to be a week or two before I can get you the install file. There are a few couple small bugs that we still need to work out, but yeah, we're just really excited to make this available. So are there any questions? Yeah, Nikki? Mm-hmm.
Do you want us to actually fill in those blanks? So let's just say there's actually no windows, right?
Mm-hmm. Mm-hmm. Yeah, good question. Yeah, let me paraphrase your question, see if I'm understanding it correctly. So if you have an EPL file and you determine that the modeling capability is too limited and you need to export it to Energy Pro 5 full, and you export it to that full file, and you're seeing that it's populating with whatever you entered in Energy Pro Lite, And if you want to change that, sure. Like in the example of window geometry, that they're kind of all over the place, and you don't feel like you can average it within Energy Pro Lite. I guess I would preface this: if you can make it work in Energy Pro Lite, you can hammer it into some sort of average. Do it. It's going to save you a lot of time. If you can't, and you do go to Energy Pro 5 Full, in the Windows example, you can go into those. If you're familiar with using those tools, what it's going to do is average everything from the EPL file. So you're going to have to go back and look at each of those independent elements within the building tree and edit them to be specific to whatever condition you're finding on site. So you're more than welcome to do that. It might be a little slightly more accurate, but if you can average it and document that in some sort of clear spreadsheet, I'd recommend just keeping it in EPL.
There are also a few online questions.
Okay, we've got some online questions.
All right, so someone asked, what if there is more than one HVAC type? Will a second model need to be created splitting up the site? I can address that.
Yeah, go for it.
If at all possible, you can try to average the HVAC types if that's applicable. However, if you have like a heat pump and a wall furnace and two different buildings, but it is still one site, you could do two separate models and then combine the baselines together. But what might be better would be just to bring it into Energy Pro 5 and then separate out that HVAC type in there. And then if it's reasonable, bring it back into Energy Pro 4.0 and then to kind of get the line-by-line energy savings per measure. And again, in the user guide, there's more guidance on how to do that.
Yeah, I'm not sure I mentioned that. You can export to Energy Pro 5 Full and then import it back to get that document if you want. So you've exported it to Energy Pro 5 Full. You've done all the changes that you can only do specific to that. You can then save that BLD file, import it back into EPL, and get that owner-facing document in the format that you want it based on the information that you entered in Energy Pro 5 Full. You cannot, and you just don't want to bring it back into Energy Pro Lite from Energy Pro 5 Full and then edit it in Energy Pro Lite, correct? Like you wouldn't want to export the file from Energy Pro Lite, make the updates that you feel you need to make in Energy Pro 5 Full, bring it back to Energy Pro Lite, and then edit again what you've already entered in Energy Pro 5 Full. I think you're going to run into issues there.
So when you bring it back into Lite with a BLD file, there are certain areas that will be grayed out that you won't be able to edit, but there are some areas that you will be able to modify. And we could do a quick demo on what that looks like. But for the most part, you will need to re-enter all the efficiency measures or confirm that they are still the same on your Energy Pro Lite 4.0. So there will be some areas that basically, because Energy Pro 5 doesn't have all of the data entry that we have in Energy Pro Lite 4.0, there will need to be some adjustments made when you bring it back into 4.0.
Okay.
It should be very minor.
Mm-hmm. Any other questions from folks online?
Yeah, so someone asked how to model hydronic/hot water convector fans on a central heating system.
So that's where you have a central heating hot water system instead of some sort of baseboard radiator. It's cycling into a wall unit that has a fan that's blowing over basically hot water in a pipe.
Yeah, I think you could get this information from any of the Energy Pro 5, 7 guidelines, but it would just be entering in the BTUs as a hot water on the HVAC element, and then you're adding in a fan that's intermittent on the alternate side. So I think it's a pretty straightforward.
Yeah, so it's
nothing different.
Back to the EPL, the per unit BTU, you calculate that for the number of those fans that are in the unit, and then average that across the property per unit, put that into EPL, and then add some fan information to that as well. So it's the same as how we modeled the heating hot water, just with the fan info added as well, right? Yeah.
Yep. And
Any other questions?
one last question. What if you have both electric and gas boilers? I'm assuming, can you add both? Can you model both? Again, this would be the same sort of situation where if you have two really different types of water heating systems, it would probably be best to bring that into Energy Pro 5 and model that separately. Although if it is two really distinct buildings, you would be able to model those separately, and then you could combine the baselines kind of externally. So there's a couple ways you could go about that. And then also, can solar, heating, or other renewable sources be modeled? So for solar thermal, we can model that, just as it's done in Energy Pro 5, kind of the same basic calculation, but we are still working on PV.
Yeah.
Correct, yeah.
So for existing thermal, you'd do all of your modeling in EPL and then export it to 5 and put in the solar fraction, right?
Yeah.
Okay. All right. Next slide, please. No. Yes, definitely. Perfect segue, Brian. So that's it. I know we blasted through a lot. I'm here to answer questions via email. You got my number there too. There's already, do you actually mind just bringing up that link? We've created a page for you guys for documents. I've uploaded digital versions of the individual user agreement, the terms and conditions, the user manual. I'll be putting up soon a link to the bug reporting form. Anything else I want to put up here? Can't think of it off the top of my head. So that's a good resource for y'all. So yeah, thanks for your attention. And for anybody on the phone, thanks for joining in. And we look forward to working with y'all.